All right, let's talk about the Doppler effect. You've all experienced the Doppler effect, even if you've never known the name for it. It's that thing that happens when you're standing on the sidewalk and a car comes towards you, and as it comes towards you, it goes wee, and it gets louder and louder. So it's wee, and then it passes you and it goes woo, it goes wee. Woo. And every time that happens, you should notice that as it's approaching you, it's a high tone. The frequency is higher. And as it goes past you, suddenly the tone, the frequency drops to a lower frequency. This is the Doppler effect, that as objects are approaching, the frequency shifts higher, and as they're moving away, the frequency shifts lower. So I'm going to start my explanation by talking, instead of an object approaching you and moving away from you, I'm going to talk about you approaching an object or moving away from an object. So I have my object right here. Let's just call this some kind of bell or something that's making some kind of wave that's radiating outwards. Now, if you run towards this, let's start with you standing right here. If you stand there, then those waves, as they spread out, you're going to get hit by a wave, hit by a wave, hit by a wave, hit by a wave. And you're going to hear, or you're going to be hit by the waves at the same frequency that they're being emitted. So in that case, because you're both stationary relative to another, you will hear the true frequency that's being produced, or the emitted frequency. But if instead you run towards the bell, as you're running towards the bell, even though it's still emitting the exact same frequency, as you run towards it, you're going to hit a wave, hit a wave, hit a wave, hit a wave, because you are moving into the wave as the wave moves towards you. So because you're hitting the wave, hit, 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 the frequency just went higher because you're moving into the waves and you're hitting them more frequently than if they were just moving out naturally towards you. And because the frequency increased, as you're running towards the bell, you will hear it at a higher frequency than it actually is. If, on the other hand, you're near the bell and you run away from the bell, in that case, you potentially could be running, well, no matter what, you're going to be hit by the waves less frequency because you're kind of moving with them. So as you move forward a little bit, the wave itself moves forward also. And so it takes you longer to get to the wave and longer to get to the wave and longer to get to the wave. So now the frequency has dropped and you hear it as a lower note. This is called redshift and blue shift if we're talking about light. If you were in a rocket ship moving towards the planet Earth would seem bluer. That means that the things that are yellow would look a little bit greener. The things that are green would look a little bit blue. The things that are blue would look a little bit purple. Everything's shifting a little bit more towards the blue side of the rainbow if you're accelerating towards it or moving towards the Earth. If you're moving away from the Earth, that means that you're moving with the waves, so you're being hit less frequently than the frequency that the wave is actually being emitted, or each wavefront. And at that point, the Earth would be redshifted, and you'd be able to tell that either you or the Earth is moving away from each other. So this is the Doppler effect. It's the appearance of shifts in frequency based on relative movement between the object that's emitting the sound and the object that's experiencing the sound. This works just as well if the object is moving. Right here, I have the object that's moving. You can kind of see that the center of the object as it's emitting each new wave is moving downwards. And because of that, because each time that it emits like the next wave, it's a little bit further forward, you get these like concentric circles that um, aren't quite in the overlapping the same way. And this bunched up area here, if you're in front of it, then you're hearing the first wave that was emitted first, but then the next wave comes to you a little bit faster than it's actually being emitted because the source moved closer to you. And then the next wave hits you a little bit earlier than it would have if the object wasn't moving, because again, the source is that much closer to you. And so your experience again is that the frequency is a little bit higher. If you're on the other side, or if the object passes you though, now each time that it's emitting the wave, it's further away. So it takes longer for the wave to get to you, and you get the impression that the frequency has decreased. Now, the emitted frequency hasn't changed. It's still the exact same frequency that the car or the bell is emitting. It's just your experience of that frequency that has shifted. So that is the idea of the Doppler effect. That's pretty much all there is to it. Thanks for watching.